I'm Shikha, you're watching this video from justtutors.com. So today we are going to learn about cube roots. In this video, I'm going to give you some introduction about cube root, and then I will teach you how we can find cube root by using prime factorization. So here, there is a warm-up for you. What you can do, just pause the video, try these two questions. Assuming that you have done them, we can check the answer now. So here we need to find the cube root of 27, which is 3. As 3 times 3 times 3 will give you 27, and here we need to find the cube root of 64. So it will be 4, because 4 times 4 times 4 will give you 64 as the answer. So if you got them as the answer, that's really amazing, and if you didn't understand, don't worry, because I'm going to teach you that in this video. So here, let's move here. So why we are learning about cube root? Suppose somebody will ask you to find side of a cubical tank whose volume is given to you. So that time this cube root is going to help you. So here, first of all, finding the cube root is just the inverse of finding cube. So here, this is a symbol for cube root. So let me explain you the symbol. So this sign is a radical sign. This, the number inside it, is a radicand, and this is the index. So this is square root. In square root, you can write index or you cannot write index. That's one and the same thing. So they both are same. But when you're dealing with cube root, it's really important for you to write 3 as an index. So now here, if a number is a perfect cube, then you can find its exact cube root. If a number is a cube, then you can find its exact cube. So here, 3 cube is 27, or we can, if we need to find the cube root of 27, we can find in this way. We can write 27 as 3 cube, and from these 3 I can pick one outside and it will become 3 there. So the cube root of 27 is 3, or we can say the cube of 3 is 27. So both are correct here. Now here, let us see this question. Here we need to find the cube root of 216 by prime factorization method. So this they have done for you. Now when you're going to make them in pairs, this is one group and this one is the other one. From these two groups, I'm going to pick one from each, like 2 from this group, 3 from this. So 2 times 3, which is 6, and that's the answer. So here, the cube root of 216 is 6. So in this manner, with the help of prime factorization method, you can find the cube root of any number. So now let us try one more question here. Let's try this one. So here, I need to find the smallest number by which 256 must be multiplied to obtain a perfect cube. So since 256 is not a perfect cube, so after doing prime factorization here, when I'm going to pair them, so this is one pair, this is the other one, and this I cannot pair because for cube I need a number multiplied by itself 3 times, but there are only 2 numbers. So what I'm going to do, I'm going to times it by 2 here to make it another pair. Similarly, I need to times 2 here as well. So here this will become 512, and here, so if I need to find the cube root of this, so I'm going to pick 1 2 from here, it will be 2 here, 1 from this one, and 1 from this one. So it will be 2 times 2 times 2, which is 4 times 2, 8. So here the cube root for this number is 8, but here in the question we need to find the smallest number, that is 2 here. So now let's move to a practice time. So let's try here number 1. So here I need to find the smallest number by which 121 must be multiplied to obtain a perfect cube. So 121 after prime factorization I can write as 11 times 11. So to make it a perfect cube, I need to write one more 11 there, and same with this side. So now it will become a perfect cube, and the smallest number here to be multiplied is 11. So you can also check your answer here. So it will become 1331, and this is the cube root of 11. So you can also find cube root here. Now what you can do, just pause the video, try rest of them. Assuming that you have done them, you can check your answer from this slide. So if you got the correct answer, that's really amazing. Thank you for watching the video. For more, please visit justtutors.com.